AI systems are conquering our hardest tests right now. They're acing math Olympiads and competitive programming right out of the box. And yet, if you look at the metric that actually matters, economic output, the impact has been surprisingly muted. We've got a utility problem on our hands. Benchmark victories keep piling up, but we just aren't seeing measurable transformation in core industries. Why? Because current evaluations only measure abstract competence. They don't test an AI's ability to carry out long-horizon, economically valuable work in an actual professional environment. Today, we're unpacking a foundational new evaluation method designed to bridge that exact gap. It's called Agent's Last Exam.
So, what happens when we test our frontier AI on actual professional workflows? 0%. That's right. The strongest configuration tested, the Codex agent harness paired with the GPT 5.5 foundation model, scores a flat 0.0% on the hardest tier of this new benchmark. Total failure. To really grasp the gravity of that 0.0%, we need to understand how we've been testing AI up until now.
Section 1. Old tests versus real work. The issue is that old benchmarks fall short because they essentially force a compromise. Think about knowledge tests like MMLU. They measure abstract trivia, not actual task execution. Others, like OS World, evaluate isolated graphical interfaces, or Terminal Bench, check-in command lines. But they rarely test both working seamlessly together. And then you have evaluations like GDP-Val that rely on expensive human grading to review project deliverables, which just doesn't scale. Agent's Last Exam fixes this. It demands long-horizon workflows. It forces the agent to interleave full-stack interaction, natively moving between graphical interfaces and command line operations. Most crucially, it uses auto-verified scoring with deterministic checks against expert-provided references. That completely eliminates the need for human judges.
And Agent's Last Exam isn't some narrow synthetic test either. It spans exactly 55 industry subfields organized into 13 major clusters. We're talking engineering, life sciences, business, finance, and legal domains. The researchers anchored these directly in the widely recognized SOC 2018 occupational taxonomy. That gives us a broad, structural reflection of the actual economy rather than just a closed-off walled garden.
In total, this benchmark contains 1,490 authentic task instances, and they weren't invented in a lab. Over 250 domain experts submitted actual project workflows they've completed on the job. The tasks demand a union of capabilities that older benchmarks only ever test in isolation. This is real, economically valuable work.
Section 2. Testing generalist AI agents.
To tackle these tasks, we're looking at a specific architecture known as the generalist computer use agent. The researchers break this anatomy down into 5 functional layers. First, the brain, which is your underlying large language model. Then the eyes, handling graphical user interface perception. The body acts as the orchestrator for overall coordination and control. The hands represent tool usage and API calling. And finally, the feet ground the agent in the runtime environment using virtual machines or shell interfaces. A functioning agent has to utilize all 5 of these layers in a single action loop to successfully navigate these complex, interleaved workflows.
Now, to evaluate these complex agents reliably, the benchmark uses a rigorous 3-phase automated pipeline running entirely in remote virtual machines. First up, the load function declares the task description and metadata. Next, the start function provisions the virtual machine into a deterministic starting state, pulling in all the necessary software and assets. Finally, the evaluate function automatically scores the output deliverables against hidden ground truth artifacts. This strict decoupling means you can test any conforming agent reliably, and it completely removes human bias and manual grading costs from the equation.
Section 3. The final frontier.
Okay, here's the reality check. Codex paired with GPT 5.5 hits a 38.1% pass rate on the easier near-term tier. On the last exam tier, though, 0%. Claude Code running Fable 5 gets 34.3% on near-term and exactly 0% on last exam. Cursor with GPT 5.5 manages 32.1% on near-term, but it only ekes out a mere 2.6% on the last exam difficulty. The performance cliff is stark. Our best systems simply cannot sustain performance when workflow complexity reaches the boundary of actual professional judgment.
The authors classified the failed tasks for the Claude Code harness paired with Opus 4.7 into a strict taxonomy to figure out exactly what was going wrong. It turns out, roughly 75% of failures fall under understanding and approach. It's a lack of domain knowledge, not raw execution capability.
Because they lack specialized expertise, the agents just default to writing ad hoc scripts instead of actually using the intended, complex domain software. In fact, only about 25% of the failures are purely execution or implementation errors.
So, what dictates this performance ceiling? It turns out that changing the foundation model while keeping the OpenClaw harness fixed creates a 16.8 percentage point spread in performance. On the flip side, swapping the harness while keeping the GPT 5.5 or Opus 4.7 models fixed only yields a 4.9 to 7.2 percentage point split. That tells us the foundation model's reasoning and domain knowledge dictate performance roughly 3 times more than the specific agent harness engineering.
We started with a 0% pass rate. History shows, though, that once a domain is captured by a verifiable benchmark, progress accelerates exponentially. If frontier AI agents eventually pass this last exam, and assuming this generalizes across the broader industry, is that the moment our economy fundamentally transforms? That is the benchmark we're watching now.
In the upcoming video, we're looking at a paper where researchers handed AI agents 153 real-world tasks across 144 live production websites. No sandboxes, actual platforms, everyday tasks, book a flight, fill a form, buy something online. Frontier models completed barely 1 in 3. I post every Monday, Wednesday, and Friday. See you in the next one.